Okay, what is this point G? What is this point G? Well, what are...
It's the in center.
Centroid. Because it's where all of the what meet?
Centroids meet. Medians.
Medians. Okay, the medians meet at the centroid. The altitudes meet at the orthocenter. I'm not just writing this up here for my health, guys. You need to know these. It will be 4 questions on your test. They should be the easy ones. Don't get them wrong. All right, perpendicular bisectors meet at the circumcenter. And angle bisectors meet at the incenter. Which one or ones of those can be outside of the triangle? Which ones have to be inside? Which ones could possibly be outside? Altitudes can be outside, and orthocenter might be outside, and circumcenter. In-center always has to be inside, and centroid always has to be inside. All right, so in-center means it needs to be inside, and centroid always has to be inside. The orthocenter and the circumcenter could feasibly be inside, but they won't always be. Sometimes they're outside. In a circumcenter, if it's a right triangle, where is the circumcenter always going to be?
The hypotenuse.
On the hypotenuse, where? In the middle, at the midpoint of the hypotenuse. Good. So it's easy to find the circumcenter, well, not easy, but it's easier to find the circumcenter of a right triangle than it is to find the circumcenter of any of the other ones. Okay, I threw 6 out because we're not going to do finding the actual orthocenters, right? So for these, you just need to really focus on the centroid-median combination. And we know that if it's a centroid, which G is a centroid, how do you know that G is the centroid? I don't have any words up here. I don't tell you anything, but I know without a shadow of a doubt that G is a centroid. How do I know that?
And you can tell the medians meet there.
It's, Jennifer, what?
All the medians meet.
Yeah, how do you know that they're medians?
Because they got the lines around.
Yeah, because look at the walls of the legs of the triangle. If this is congruent, like right here, if AD is congruent to DB, then that means D must be the what? If this is congruent to this, that means D must be the, someone just said it, midpoint. All right, if CE is congruent to EB, then E has to be the midpoint. And if AF is congruent to FC, F must be the midpoint. And since they go from the vertex to the midpoint, then they have to be medians. Therefore, this has to be a centroid. Since you know it's a centroid, what's the relationship between the shorter piece and the longer piece?
Oh, one's the smaller one?
Mm-hmm.
If you multiply by 2.
Okay, if you multiply the smaller one by 2, it gives you the bigger one. And then what do you do to find the whole thing? Add them together. What if you have the whole thing? Why do you divide it by 3 and not divide it by 2?
Because of triangle.
It's a third of it, because it's a third of it. The small piece is a third of it, so you double it to get the bigger piece, but if you have the total, if you divide by 3, that gives you the smaller piece, and then what do you do to get the bigger piece? Multiply that by 2. Okay, good job. So centroid medians will be a big focus going forward. That's one of the big things you need to remember from this chapter. All right, we are going to talk today about mid-segments, the mid-segments of a triangle. And then this is the last section before you guys have a quiz. So your quiz will be on 5.1 to 5.4, and it is on Tuesday. Tuesday you guys have a quiz. Okay, your homework's not due because it's not a test, but you have a quiz on Tuesday. So the mid-segment of a triangle is a segment that joins the midpoints of the 2 sides of the triangle. So we talked on Tuesday about medians. which went from the midpoints over to the opposite vertex. But here we're talking about midsegments. So for example, FB right here is a midsegment because essentially you're just connecting the midpoints in a triangle. All right? So FB is a midsegment, FD is a midsegment, and BD is a midsegment also because DB connects these two sides, AC and EC, and then FD connects these two sides, AE and EC, and so on. And so these are midsegments. This triangle right here is called a midsegment triangle. All right, triangle FBD right here is a midsegment triangle. It just means it's a triangle made of midsegments. In triangle GHJ, show that the midsegment KL is parallel to GJ and that KL equals half of GJ. So, how could I do that? Let's do the first part first. How can I prove that KL is parallel? How do you prove that things are parallel? In a coordinate plane, how do you know that things are parallel? Find the slopes, because Charlize, they should do what? The slopes of parallel lines are the same. So if you find the slope of KL, it should be the same as the slope of what? GJ. Should be the same as the slope of GJ. Okay, how do I find the slope of KL? First find the points. So what's the coordinate of L? Negative 2, 4. And what are the coordinates of K? Negative 3, 4, 5, 6. Negative 6, 2. Good. Negative 6, 2. Okay, so then to find the slope, plug it into the slope formula for me. What would that be? Give me 4 minus 2. This is KL. Over negative 2 plus 6, because it's minus a negative. What's 4 minus 2? And what's negative 2 plus 6? 4. And that reduces to what? All right. And then the slope of GJ. Give me the slope formula for that one.
2 plus 2.
It doesn't matter. Does not matter. No, it doesn't matter. As long as you pick, as long as you use the same coordinate for your first ones, it doesn't matter which is which.
1 plus 7.
Okay, and then 1 plus 7. And that gives you 4 over 8, which reduces to what? 1 half. So are those parallel? Yes. Okay, so there's your coordinate proof for the first part. And then the last part says that KL is half of GJ. So how can I prove that? How can I? Almost. Not the midpoint. What's the distance formula? What is the distance formula?
D equals the square root of. Isn't it x1 minus x2 squared plus y1 y1
Okay, so give me that for KL. What's x1?
4.
For K?
Oh, I mean 2.
Negative 2, right? Or either one, it doesn't matter. So negative 6 plus negative 2, minus negative 2, which becomes a plus, what's y1? Are you guys awake today? No? Okay, 2 minus 4 squared. What's negative 6 plus 2?
Negative 3. Oh, I'm sorry.
Negative 4. Negative 4 squared is what? 16. Plus, what's 2 minus 4? Negative 2. Negative 2 squared is 4. So 16 plus 4. So this ends up being the square root of what? 20. Do I need to simplify it? No, just leave it. Leave it alone. Okay, so that's KL, and then we need to find GJ. So GJ would be, what's your x1 for GJ? Negative 7 minus squared plus negative 2 minus 2 squared. What's negative 7 minus 1? Negative 8 squared would be 64. Plus, what's negative minus negative 2 minus 2? 4 squared is 16. And that gives you square root of 80. Okay. Not again. All right, square root of 80. Does somebody have a calculator? Can someone grab a calculator? Can you do the square root of 80 and the square root of 20? Take your time. The board's not working anyway. I don't even know what that light is.
What's the other one?
20. I have no idea. I've never seen it before.
And then 5.
Wait, so you do the distance between each of them?
Hey. All right. So, Charlize, give me one more time.
So it says
Square root of 80 was what?
it's 4 and then square root 5.
Are these 4 root 5? And then this is
It's
2 root 5? Good. Okay, eyes back up here. Sorry, guys. Eyes back up here. So is 4 root 5 and 2 root 5. Is KL half of GJ? Yes. So you've proven that the distance from KL to GJ is half. Okay, so that's called, all that information goes together for the midsegment theorem. The triangle midsegment theorem tells you that if a line segment is a midsegment, so for instance, in this triangle, so if DF is a midsegment in this triangle, that means DF is parallel to BC, and it also means that DF is half of BC. Okay, so the triangle midsegment theorem will tell you those two things. That's it. So how do we use that?
all that.
Yeah, you could. Or if I tell you something like this, x plus 8, and this is 4x plus 6, and I tell you that that's a midsegment, what could you do to solve for x? All right, so then what? Now what?
You
Subtract
subtract 2.
2x and subtract 6. 10 equals
X. Oh, negative 2. None. What is that?
2x, because 4 minus 2 is 2.
And 5.
Divide by 2, divide by 2. So x equals what? 5. What? Where is this 2 from? Gabe, where'd that 2 come from? Yeah, because the triangle midsegment theorem says that this midsegment, let's call it AB. AB is half of CD. Therefore, to use this, we'd have to double that to get the lower one. Tiara, what'd you say? Okay. Okay, so I want to find each of these measures. I want to find UW and I want to find the measure of angle SVU. So UW is where?
It's the mix.
It's right here, right? UW is right here. So if UW is a midsegment, which it is because it connects two midpoints, which line segment, which side of the triangle does it go with? ST. All right, so if ST is equal to what? Because if this is the midsegment, then this right here is the triangle side that it goes with.
How come not UV?
Because UV is right here. That's inside the triangle. So again, if you think about it like this one has to go with this one. Like this one right here is in a relationship with this one.
So like I don't look at UV.
What?
Like
Don't look at UV right now. No. Only look at UW and ST. Okay, so if ST is equal to 7.4 then, how could I find UW? Divided by 2. And that would give you what? Can you sit up? 3.7. It's what? Oh, okay. How would you find the measure of SVU? Oh yeah, I didn't even notice that.
Oh wait, isn't it like 41?
What is it?
Yeah, okay, why is it 41?
UW and ST are parallel.
Guys, I suggest listening. So UW and ST are parallel because it's a midsegment. So that this right here is a what? Transversal. So then if this one is 41, what is this one? Why? They are alternate interior angles. Again, remember what I said. Anytime you see parallel lines, what should you look for? Alternate interior angles. Whenever you see angles or lines like this, what type of angle should you look for? Vertical angles. Whenever, what's the other thing you should always look for? No, what property? Reflexive property. When do you use the reflexive property?
When they share
Shared side. Shared side or angle, I guess. Okay, go do these 6. Yes, go do these 6.